So starting from relation and functions. A relationship between two quantities can be visualized using an input-output machine or a table or a graph. So if I have a input-output machine and there is some function happening here, input is x here and output is y here. So let's say this is a table, time and height. So we have examples over here and we will understand this concept with the help of the example. So what is this figure? This is called table. What is this? This is input, that is x. This is output, that is y. So what is this over here? This is a graph. What is this graph representing? This graph is representing weight in the kgs and the kilometers that are run per week. So this figure is known as graph okay. And the bottom line, the horizontal line, this is called the horizontal line. In this line is known as input. The values that we insert over here are the input values. The values that we insert over here are called output values. So this is a graph. This figure is called graph. The horizontal axis contains the input. The vertical axis we have output. This is a table. The first one is column is input x and the second one is height, it is output y. So this is what input and the output of a function is. So now let's work on what a function assigns exactly 1 point y value to each 1 point x value. So for each one point to each x point, exactly one output for one input. For one input, if we have only one output, one input and one output, then it is called a function. If it's one input, more than one outputs, this is not a function, this is called a relation. So what is a function? If we have one input and one output, it is called a function. If it's more than one, then it is called a relation. Okay, now we need to know that how, if a function is given and we are asked that whether it is a function or not, how we can tell them that if it's a function or not. So we have vertical line test. This test is also known as VLT test. Okay, what does vertical line test says? If you can draw a vertical line that crosses or touches the graph at more than one point, then graph does not represent a function. So if we have a graph and we will draw a vertical line and that vertical line cuts more than one point, then that does not represent a function. For example, I have this graph. I'm going to draw a vertical line. It is cutting on the function on one point. I'm drawing a vertical line. It's cutting on the function on one point. I'm drawing the vertical line. It's cutting on the function on the one point. Okay, let me tell you what is the function over here. This line that is moving across like this, that is called basically the function. And if I will put the vertical line anywhere, it will cut the graph on only one point. So this graph is a function. Now let's take the example of such a graph which is not a function. Let's take this example. In this blue line, I'm working with the purple, this is a graph. And if I will put a vertical line over here, it will cut the function on graph on the 2 points. So it's cutting the graph on more than 1 point. So it's not a function. This is the called vertical line test, and with the help of this test we can decide that either the given graph is a function or not. Okay, so this fails the vertical line test, therefore this is not a function. Okay, so exercise 1 is decide whether each of the following represents a function or not. Explain your thinking. So I have some input and I got some output. The value of the function is y is equal to 2x minus 1. So let's assume y is equal to 2x minus 1. So how to make a graph? You have the values of x, y. You need to plot some values. If x is 0, 1, 2, minus 1, minus 2. Let's, for example, what will be the values of y? If x is 0, 2 into 0 is 0, minus 1, it would be minus 1. If x is 1, 2 into 1, 2, minus 1, 1. X is 2, 2 into 2, 4, minus 1, 3. If x is minus 1, 2 into minus 1, minus 2, minus 1, minus 3. 2 is minus 2, minus 4, minus 1, minus 5. Okay, so we have got some values for x and y. Now we are going to plot the graph like this. Okay, for some values of x, okay, if our x is 0, 1, 2, minus 1, minus 2. Okay, now let's plot the values of y. X is 0, y is minus 1. X is 1, y is minus 1. Y is positive 1, sorry. Okay, x is 2, y would be 3. X is minus 1, y would be minus 3. X is minus 2, y would be minus 5. Now let's draw a line to connect all these points. Okay, so now we have drawn the graph for y is equal to 2x minus 1. Now I'm going to have vertical line test. What does vertical line test says? Draw a vertical line at any point of the graph. It cuts the graph at one point, cuts the graph at one point, cuts the graph. Anywhere if you will draw a vertical line, it will cut the graphs on one point. So it passes the vertical line test. Therefore, it is a function. Okay, coming to the next B. Okay, for one input value we should have one output. For one input value we should have one output, but for one input value I am having two outputs. So if I have two outputs for a single input value, it is not a function. If I have single input and two outputs, then it's not a function. Coming to the point C. Let's take a vertical line test. Draw a vertical line anywhere. It's cutting the graph at 2 points. So it's cut the graph at 2 points, so not a function. Why? Because VLT, vertical line test, fail. The last one is D. I have the x values and I have the y values. X means the input values and y means the output values. So for one input value I should have one output. For 0 I have one output, it is minus 3. For 2 I have one output 0. For 0 I have the output minus 3. For 2 I have the output 0. For 4 I have the output 3. For 6 I have the output 0. For 8 I have the output minus 3. So for one input I am getting only one output. Because for one input I am getting one output, so this is a function. Okay, now as we have learnt about it, what is a function, we're coming to one-to-one functions. Some relations are functions and some functions are one-to-one functions. A function is one-to-one as if and only if the output y value never repeats. So uh, we have relation. All relations cannot be function. All functions cannot be one-to-one functions. Okay, so to be known that if a function is a one-to-one function or not, we have another test that is called horizontal line test. With the help of horizontal line test, we can identify it if the function is one-to-one or not. If you can draw a horizontal line that intersects the graph of a function at more than one point, then graph does not represent one-to-one function. For example, I have this graphs, and if I will draw a horizontal line over here and it does not uh, cuts the function at more than one, it cuts the function only at one point, then it is a one-to-one function. I will draw a horizontal line, it cuts the function on 2 points, so it is not a one-to-one function. So for a graph to be a function, we have to take the horizontal line test, vertical line test, and for graph to be one-to-one function, we need to take horizontal line test. Secondly, for graph to be the function, one-to-one function, if and only if output value never repeats. So the value of the y should never repeat over here. Okay, classify each of the mapping as a relation or a function. If it's a function, decide whether it is one-to-one or not. Okay, for is the output value repeating? Output value is not repeating, so it is 1 2 1 function. Okay, is output value repeating? Yes, because for the input 1, the output is 4. For input 0, output is again 4. So output value is repeating, so therefore it is not one-to-one. Okay, is output value repeating? Output is not repeating. Okay, for this function, coming back to this part, let's first check it if it is a function or not. It's not one-to-one, but what about function? For the function, every input should have only one output. For every one input, we have 1 has the output 4, 0 has the output 4, minus 3 has the output 4. So input is not repeating, so it is a function. It is function, but it is not one-to-one function. Now here input is repeating. 1 has the output 4, 1 has the output 5. If the input repeats, it means it's not a function. Whenever input repeats, it's not a function. Whenever output repeats, it's not one-to-one function. So here we have learned about what is one-to-one function. Okay, the domain of a relation represents set of all possible inputs x values for the function, and the range represents set of all possible outputs y values. So what is domain? I have also make another video about the domain and the range. So what is domain? Contains all the input values, and the range contains all the output values. So we will always state the domain in the range with the smallest to the largest values. Use the graph on the right to answer the following questions. Okay, does the graph represent a function? Is it one-to-one? How can you tell? For one-to-one, okay, first question is, does it represent a function? For the function, we have vertical line test. Let's take vertical line test. The graph will cut only 1 point. Vertical line test, graph will cut only 1 point. Vertical line test, graph will cut on 1 point. So the answer for the first question would be yes, it's a function, and the reason is passes vertical line test. Okay, coming to the second question, is it one-to-one? Taking horizontal line test, it cuts the graph on the 2 points, so it is not one-to-one function because it fails horizontal line test. Okay, Coming to the second question. Daniel thinks the domain of g of x, this is the function g of x, the domain is -2, -1, 0, 1, 2, 3, 4. Is he correct or not? Okay, what is the domain? Domain is the all the input values that a function can take. All the input values. So the function is starting from -2 and the function is ending on 4. So how many values are there between 2 and 4? So this is a very common question. How many values are there between two numbers? Between any two numbers of a number line. So the answer would be infinite values. We can never count them. So if the function is starting from -2 and ending on 4, so it means the domain contains all the input value. What is domain? All the input values. So how many input values are there from -2 and 4? It would be infinite values. So because the infinite values, so Daniel thinks it values are the values that are only represented on the number line. It is -2, 1, 0, 1, 2, 3, 4. And this is the wrong answer, since there are infinite number of x values on this section of the graph. So is he correct? He is incorrect. As there is infinite number of values in this section of graph. Okay, part C is what is the actual domain for g of x. So now what will be the domain for g of x? Domain means all the input values possible for this graph. So what are the possible values? -2 is including, and 4 plus 4 is also including. So x would be greater than or equal to -2, less than or equal to 4. We can also write it in the -2 close bracket and +4. Close bracket means that the number is included. So the domain, again I'm telling you what is the domain for g of x. Domain means all the values. The graph is starting from -2 and it is ending on 4. So all the x values on the x-axis are coming on the domain. It is from -2 and 4, and -2 and 4 are including. Therefore we will write -2 less than equal to x less than equal to 4. Which y values are valid for this graph, or what is the range of g of x? Now what will be the range of g of x? Range is always the y values. So the y values for this graph would be 2, 3, it's going upwards till 3, and downwards it's going till -1. So it's from -1 to 3. -1 less than equal to y less than equal to 3. It can also be written as -1, 3 in the square brackets. Okay, interval notation. There are a couple of ways to express a set of numbers for domain and range. Leave this. We will focus on interval notation. Interval notation uses different kinds of brackets to indicate if the point is included in the domain or range or if it is not. A square bracket includes the end values and the round bracket does not include. So if you have a round bracket and it's written 1, 2, it means 1 and 2 are not included in this bracket. In the number line, if it's 1, if it's 2, 1 and 2 are not included. All the numbers between 1 and 2 are included. But if I have written square brackets 1, 2, it means 1 and 2 both are included. Also the numbers between 1 and 2 are also included. So this is the difference between the coming to the interval notations. There are a couple of ways to express a set of numbers for the domain and range. If we focus on the interval notation uses different kinds of brackets to indicate if a point is included in the domain or range or if it is not. A square bracket indicates the end values and the round bracket excluded the end values. So if I have a round values and I have the values 2 and 4, round bracket means the 2 and 4 is not included. Round bracket excluded the end values. If I have square bracket 2, 4, it included the end values, means 2 and 4 are included. Okay. So consider the partial parabola at the right. Note the point 10 is closed dot, but the point 43 is open dot. So if you have this colored dot, it means it's closed. If you have like this uncolored dot, the white one, the unfilled dot, that is open dot. So unfilled dot is open dot. Okay, so this means that 10 is the point of the graph, 10 point lies on the graph, but the point, this one, that is 4 from the x-axis, 3 from the y-axis, this point is not lying on the graph. All the points below this do lie on the graph, but this point do not lie on the graph. So what is happening? If you have a closed dot, it means that point means 1 from the x-axis and 0 from the y-axis. 1, 0 is on the graph. If it is -1 from the y-axis and 2 from the x-axis, it means this point is on the graph, but this point is an open dot. So if it is an open dot, it means the point 4, 3 is not included in the graph, not included in the graph. So what is the domain and what is the range of this graph? So what is domain? The x values are known as domain and the y values is called range. So whenever you need to find, you need to look the x values. So the graph starts from here and the graph ends over here. So the x values from here to here are 1 is included, so close interval. 4 has the open dot, so 4 is not included, so the open interval. What is range? Range means the y values of the graph. So graph is below, it is at -1 and up it is at 3. So -1 has filled dot, so -1 is included, close bracket. 3 has the open dot, so 3 is not included, open bracket. So in this way we can calculate or write domain and range. Domain means the x values, range means the y values. Okay, now coming to the next question, write down the domain and range for each of the following functions. Okay, so this function is starting from 2 and 3 over here, -1 over here. So the domain would be -1. It has the open dot, so it's not included. If it has open dot, it means it's not included. And here it is 3, so 3 has the filled dot, so it's included. Okay, what will be the range? Range will be the y values. Starting graph is from 0 and it has maximum point at 2, so the graph is between 0 and 2. Okay, around for this graph, domain is starting from +5 and going towards -infinity. So if this point was like this, if I have a dot over here, so the graph was going to end over here, but I don't have any dot over here, the line goes on, so line is going to -infinity. So domain would be -infinity and 5 has the filled point, so it would be square brackets. What will be the range? Graph starts from 0 and going upwards to +infinity, so it would be 0, +, because it's going upwards, so it's going to be +infinity. Okay, whenever there is a break in the domain, write an interval for each part of the domain, then put the union sign between each interval to join them together. Now what will be the domain of this function? Domain means all the points on the x-axis, so it is going to the -infinity and here it goes over here. What is this point? minus 3. Then we get a break over here. Okay, so first of all it's minus infinity to minus 3, minus infinity to minus 3. Okay, because this is lying over here, this, now you know this is an unfilled point, so minus 3 will have open bracket because this dot has is a unfilled point. Union, starting from minus 3, minus 3 is an unfilled point, so open bracket, comma, going till 5 and close bracket here. Now this is called the domain, or the x values of the graph. Coming to the range, what will be the range? The graph is going downward over here, so it's going to be minus infinity, and from upward it will go to so where the break will come, the break will come at the first point. The first point is at minus 3, so minus infinity to minus 3 with the open interval. Union, minus 3 to, it will go upward, 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 upward till 5, so minus 3 till 5, close interval. 5 would be close, minus 3 to, sorry, it's 1, 2 and 3, it's 3 not 5, so it's 3 over here. Okay, so what are the domain values? Domain means the x-axis values. Range means the values on the y-axis. So in this way we can find them all. Coming to the next point, write down the domain and range of each of the following graphs. Okay, so now I have the graph over here. What will be the domain of this graph? Domain means the x values, so it's 0 and it is starting from minus 1. Minus 1 is included and it will go till 5 and 6, but there is a point. If there is a point, we need to break the graph. Point is at 1, 2, 3, so graph is from minus 1 to 3, open interval, union, open interval, 3 to 6, close interval. Now I can mark the domain like this. Domain is starting from here and going over here like this. Okay, now I will mark the range. Range is the y values. Y is starting from here, that is 1, and the first point is 5, so it's going to be 1, 5 is the open interval. Union, starting from 5 going to 8, which is the close interval. Okay, now the domain and range of this graph. Domain would be starting from 0 and going to the first break 2 and then ending on the 4. So 0 to 2, it would be 0 is included, 2 is not included. Union, 2 is not included, even 4 is not included. Now range is starting from, it would be minus 1 and going to 3, so it's minus 1 which is not included, 3 which is included. Function notation. For any function, consider x values as the input, y values as the output. The function f of x is the other way of representing y values. Y is equal to f of x. F of x is equal to 3x minus 5. So we need to evaluate f to the power 4. So it would be f4, which is equal to 3 into 4 minus 5, 12 minus 5, 7. Okay, use the graph g of x to answer the following questions. Is g of x a function? First of all, we need to know if it is a function or not. So for making it a function, we know that we need to pass the vertical line test. Okay, let's do vertical line. It meets at one point. Let's do vertical line meets at one point. Let's do vertical line meets at one point. So if the vertical line, if we have can draw a vertical line, and the vertical line touches the graph at only one point, this is called vertical line test. So passes vertical line test. It is a function. Okay. Now we need to find g of 3. G of 3. This is the graph of g of x. So g of 3 would be equal to 2. This is 3. G of x means g of 3 means we need to write 3 instead of x. So we will look at the x interval or the x-axis. So at 3 the graph is at 2. So answer is 2. G of minus 1. At minus 1 the graph is at plus 1. Negative 1, sorry. G of 10. And g of 10, it does not exist. Where is g of x less than equal to 0? Less than equal to 0 means below x-axis. So below x-axis the graph is from minus infinity to union 8 to 9. Okay, this is the whole graph. This one portion of the graph is less than 0 means below x-axis. So it is starting from minus infinity and it is going till 2. Union. Then from 8 to 9. 9 is the close interval because the dot is filled. This is the graph below x-axis or less than 0. Now above x-axis. G of x is greater than 0 means above x-axis. This is the portion above x-axis. And it is starting from 2 and ending on 8. So it is from 2 to 8. Maxima and minima. The maximum and minimum of a function refer to the highest and the lowest points on the graph. The absolute maximum of a function is the y value that is greater than all, equal to all other y values of the function. So we have so many y values of the function. So the greatest value of the y value of the function would be absolute maximum, and absolute minimum would be the less than or equal to all y values of the function. Relative maximum of the function is the y value it is greater than or equal to all nearby y values, and relative minimum is the y value it is less than or equal to all nearby y values in the function. Use the graph f of x to answer the following questions. What is the absolute maximum of f of x? So this is a function f of x. So what is the maximum point that the y values are going? So this is the y, and along the y-axis the maximum point is over here, and it is on y is equal to 4. So what is the absolute maximum of f of x? It is 4. At what x value does f of x has absolute maximum? X key, which value of x? Absolute maximum is at y values, absolute minimum will be at y values, but at which value of x? It would be at minus 4. What is the absolute maximum point on f of x? So the point would be f of 4 minus 4, 4. What is the absolute minimum of f of x? So minimum means the lowest value of the y-axis. So lowest value in the y-axis would be all these three are lowest. So it means the lowest value does not exist. At what x values does f of x has relative minimum? Relative minimum, it means if all of these three values are minimum, that is at minus 3, 1 and 2, minus 3, 1 and 2. At what x values does f of x has relative maximum? Relative maximum will be at 1. The maximum is at 4. So relative maximum would be also they are asking about x values, so we need x values which are giving relative minimum, that are 3 values. Now they are asking about x values that f of x has relative maximum. So relative maximum would be occurring at minus 2 is not included, minus 1 is included. So minus 1 would be x is equal to minus 1 for relative minimum. Decreasing, increasing or constant functions. A function is decreasing on an interval of the domain when y values decrease as the x values increase. Y is decreasing, so it is decreasing function. If it is constant, then it is constant function. The whole of the domain when y is increasing, then it is increasing function. Okay. Increasing and decreasing are defined on the interval, not a specific values. It is generally more accepted that endpoints are included in the intervals where the function is increasing or decreasing unless a function is undefined at the endpoint. So we should know that if the endpoint will be included, f of x is constant. At which point will f of x be constant? This is the point, and this is starting from 1. This is the field, so 1 is included, and this is ending on 4, and 4 is not included. F of x is decreasing mean y values is coming downwards. So y value is coming downwards over here from here till this point. So this point was starting from 5, 6, 6 to from 6 to it would be minus 1. So 6 is included, minus 1 is also included. Union from here, that is minus 4 to positive infinity. And we can rearrange and write it like this. F of x is increasing from here to here and here to here. Okay, it's increasing from minus 1 to plus 1. Minus 1 is included and plus 1 is not included. Union increasing from 4 to 6. Okay. State analysis the graph of the f of x at the right by answering the following questions. State the domain. The domain of the graph is the values of the x-axis, so it's going downwards towards the negative infinity, and from here it will go to the maximum value of 5, 6, 7. So it's the domain would be negative infinity to 7. Range will be the y values, and y values are going from 4 and below it is going this is going to negative infinity. So it's going to be negative infinity to 4. State the interval where f of x is increasing. So it is increasing. Here it is going upward from here to here, minus infinity to this point 4, minus infinity to minus 4. It is increasing. Union, it is increasing from here, that is 3.5 to the upwards to 7. State the interval where f of x is decreasing. It is decreasing from here to here. So it is decreasing from minus 4 to 3.5. State the interval where f of x is constant. So is there anywhere that it is constant? No, it is not constant anywhere, so it does not exist. Identify any relative maxima or minima of f of x. So for relative maximum, y will be equal to, at 4 it is maximum, so relative maximum will be below the 4, it is 2. So y is 2 for relative maximum. For relative minimum, y would be equal to minus 4. Identify any absolute maximum or minimum of f of x. Y would be absolute maximum at y is equal to 4. Absolute maximum at y is equal to 4. There is no absolute minimum because it is just like this. Okay, locate the y-intercept, the point where the graph crosses or touches the y-axis. So graph touches the y-axis at the point this. Y touches the y is equal to minus 2. Locate x-intercept where the graph touches the x-axis. So graph touches the x-axis at how many points? Graph touches the x-axis at minus 50, then at minus 30, and last at 60. So it touches the graph at minus 5, minus 3 and 6. Coming to the problem set number 1.1. State the domain and range for each of the relation. Then determine whether the relation is a function or not. So domain. The input values is domain, that is 100, 200, 300. What is range? Output values is range, that is 50, 100, 150. Is it a function or not? So for one input value we have one output. Input value is not repeating. Input value is not repeating, so yes, it is a function. Okay, about this, first of all, what is the domain? Input values is the domain. Input values is 3. Range, output values is the range. Output values are 1 and 5. Function, for one input value there are 2 outputs, so not a function. C. Okay, we are given x and y values in the form of the table. So domain are all x values 1, 2, Range are all y values, 2, 4, 6. For one input value we get only one output, so yes, it is or domain does not repeat. 1 2 3, domain does not repeat, it means it is a function. Okay, the D part is, okay, the domain are all the x values are starting from 0 and ending at 11. So x is greater than equal to 0, less than equal to 11. We can write it in as interval notation like this: 0, 11. Range will be the y values, y starting from 2 and ending at maybe 9. So y starting from, sorry, it is starting from -2, and in interval notation we can write it as -2 and 9. Okay, now is it a function or not? Okay, for the function we need to do the vertical line test. Let's do the vertical line test. If I will do the vertical line test, it is cutting the graph at 2 points, so vertical line test fails. Not a function. Okay, domain of this function, all the values that are from x-axis. We have the point at -2, we have the point at negative, we have the point at 1, at -1, and at 3. So it's -2, -1, 1, 3. Range, points on the y-axis. In the y-axis I have point over here, point over here, point over here. So the points from the range are, here it is -4, -2, because this is 0 and 1. All the points on the y-axis would be included in the range. Now either it is a function or not. Let's join the dots. Now let's do the vertical line test. So when we are going to do the vertical line test, if I will put a line over here, it will match 2 points. So it is not a function. In other words, I can say that if I have a straight line or a constant line over here, it would not be a function. Okay, I have a constant vertical line, it would never be a function. Okay, coming to the F part, we need to write its domain, its range, and either it is a function or not. Okay, what will be the domain? I told you that if it is an arrow, it means it's moving on and there is no stop. If it's an arrow, it's moving on and there is no stop. So it's going from -infinity towards +infinity. Means x belongs to all real numbers is the domain. What is the range? From in the y-axis, it is going to -1 and it is going to +1. So minus 1 is less than equal to 1 is less than equal to 1, and in the interval rotations we can write minus 1 1. Now if it is a function or not, vertical line test. When I do vertical line test, it passes more than 1 point, so vertical line test fails, not a function. Okay. Use interval notation to describe the following statement. The domain is any number between and including. Between and including. So it is written that it's between and included means we will need the interval notation and we will need the close brackets. -2, 7. The range is any number greater than 4 but excluding 4, and greater than 4 going towards positive infinity. The domain is all real numbers except for -3. So all real numbers are from -infinity to +infinity, but we need to do it except -3. So we will write -infinity to -3, open interval, union, open interval, to +infinity. Range is any real number. Any real number means -infinity to +infinity. Find the value of f of x is equal to 2x minus 1, and here it is given f of 0. So f of 0 would be equal to 2 into 0 minus 1, which is equal to 0 minus 1 minus 1. Okay. F of -2. F of -2 is equal to 2 into -2 minus 1, -4 minus 1, -5. Then g of 0, 0 square plus 4 into 0 plus 1, 0 plus 0 plus 1, 1, -2 minus 2 square plus 4 into -2 plus 1, 4 minus 8 plus 1, 5 minus 8 minus 3. Okay, I have f12 over here, 2x minus 1. I have g10 over here, 10 square plus 4 into 10 plus 1, 100 plus 40 plus 1, 140, 141. Next question is question number 4. State the domain and range for the following relations using interval notation that determine whether each of the relation is a function, and if so, then write whether it is 1 to 1 or not. So we have to do the 3 things in this. First of all, we will tell domain range, then we will tell whether it is a function or not, and then we will tell whether it is 1 to 1 or not. So let's start. First is domain. We know domain are the x values. So this graph is starting from -3 in the x-axis and going to have a break on 4. Then from 4 it will go to positive infinity. So the domain would be -3 and break on 4, union 4 to, you know why I'm taking break on 4, because there is an point over here on the 4 on the graph, and this point is not colored, means this point is not included, so therefore I need to skip this point. Okay, now what is range? Range is starting from somewhere -infinity and having the break over here at -2, so -infinity to -2, union starting from -2 and having the break on the positive infinity, or it is stopping somewhere. If this is the end point, no, it's positive infinity. Okay, about function, either it is a function or not. It means I need a vertical line and it cuts at one point. So yes, passes vertical line test. Now let me put a horizontal line and check if it is crossing at only one point. So yes, HLT pass. Okay, question number B part, again doing the same. So the x values are going downward over here, and from here, so x values are from minus infinity to plus infinity domain, and the range would be the y values are going somewhere at 4, and downwards it's going to negative infinity, so negative infinity to 4. Function, if I will draw a vertical line, it crosses at only 1 point. So yes, it is a function, passes vertical line test. Now let me draw a horizontal line. It passes more than 1 point on the graph, so no, HLT fails. Okay, the C part is, what is the domain? Domain means the x values, and the x values are over here starting from -4. This is an open one, so -4 is not included, and going to +4, which is included. Range is the y value starting from y values, and the y values are going from, it is going towards negative infinity, zero, and ending on 4. Range would be 0 to 4. Now function, if I draw a straight vertical line over here, it passes the vertical line test. So yes, vertical line test passes. Because I draw a horizontal line, it cuts the graph on 2 points, so no, fails horizontal line test. Okay, this is a graph, very important graph. Okay, what will be the domain? Domain means the x-axis. X is at 3 and it is always moving at 3, so x is equal to 3, or 3 is the domain. What is range? Range is the value of the y-axis. So y-axis, it is going and going, so it means negative infinity to positive infinity. So function, is it a function or not? So tell me, vertical line test, is it a function or not? I will draw a vertical line over here, it passes more than 1 point, so vertical line is not a function. And 1 to 1, I passes this, it cuts only 1 point. If it's not a function, it cannot be 1 to 1. If it's not a function, it can never be 1 to 1. Okay, domain is the x values starting from, the graph is going there, so it would be somewhere negative infinity, and it's taking a stop at on the x-axis, it's going to take a stop at 1, union from 1 to 3. Now range would be from 1 to positive infinity. Function, if I draw a vertical line, it cuts only at 1 point. Yes, 1 to 1. No, it gets more than 1 point, so no, HLT fails. VLT passes. Okay, so again this is a graph and we need to know the domain. So domain is the x value starting from -5, which is not included, coming to 1, which is included, union starting from sorry, -1, +1, which is not included, and ending on 5, which is included. Then range possible values starting from 0 and 1 and ending on 5. So it would be from 1 to 5. Okay, function, yes, if we do the vertical line, it only passes from 1 point, but if to a horizontal line, passes from the more than 1 point. So not 1 to 1, but a function VLT pass, HLT fails. Use the graph f of x and g of x to answer the following questions. Okay, so I have this graph and I need to answer the questions that are mentioned below. So first of all, the very easiest question is domain. So domain is starting from here -6, and -6 is not included, and it is going to go here till 4. No, it's arrow, it's going upward, so it's positive infinity. Range is starting from here -3, which is not included, and going upwards towards positive infinity. Y-intercept, at which point graph intercepts the y-axis. Y is equal to 2 or 0 to x-intercept. The graph intercepting x-axis -3. X is equal to -3 and x is equal to, sorry, -4, -5. It is -5, not -3. And x is equal to -5. Then it is going to intercept as +3. So it would be -50, 30. Okay, state the interval f of x is increasing. Increasing mean going upwards. So let's see where the graph is going upwards. Graph is going upwards starting from -6 and it will go upward till -2. So it will start from -6 and go upward till -2. Then union, it is going down, then starting from 3 it is going upward towards the infinity, 3 and infinity. State interval f of x is decreasing. Coming down is the region from here to here. This is from -2 to 3. State interval f of x is constant. So is it constant anywhere? No, does not exist. Okay, so real maximum means the y value is maximum at, actually y value is maximum at 4. Y value is minimum at not -3. It is not included, so it's going to be 0. Absolute maximum, because it is going towards positive infinity, so absolute maximum does not exist. Absolute minimum, because the minimum point is not included, so absolute minimum does not exist. F of -4, so when f is at -4, the value of y would be 1. F of x is equal to 1. Where is f of x is equal to 1? F of x is at 1 at how many points? At x is equal to -4, +2 and 3.5. F of 0, what is f of 0? At 0 the point is meeting this -5 and -3. F of x is equal to 0. Sorry, f of x is equal to 0 at -5 and -3. F of 0 means f of x is equal to 0 at 2. Is -6 -3 on the graph of f of x? -6 and -3, that is this point. No. Where is f of x greater than equal to 0? Greater than equal to 0 means positive x-axis. So it's starting from -5 and greater than equal to 0 till positive infinity. Okay, the last one. Domain. Domain are the all x values. Starting from -9, there's a gap point at -1. Then starting from -1, it will end at 7. -9, which is included, gap at -1 not included, union -1, gap at 7, which is included. Range. Y values all are from -2 to 4. Y-intercept. The graph touches at y-axis. The graph touches at y-axis at this point. This point is y is equal to 4. X-intercept graph touches at x-axis at -9 and 6. State the interval f of x is increasing from here to here, from -9 to -1, and -1 is not included, -9 is included. F of x is decreasing. This is the constant one, so this is the decreasing one, and this is 3 and this is 7, so decreasing from 3 to 7. F of x is constant from -1 to +3. Real maximum, the actual maximum, because it is a constant function at maximum, so it does not exist. Real minimum does not exist. Absolute maximum is the value of the y. So y is maximum at 4 and y would be minimum at -2. Okay, now what is g1? Okay, find 1 on the x-axis. It would be equal to 4. g3, find 3 on the x-axis. 2, 3. It will be equal to 4. G of x is equal to 1. Where is g of x is equal to 1? G of x is equal to 1 at which points? This point and this point, 5 and -7. G of x is equal to 0. 0 at this point -9 and this point, that is 6. So we have tried to complete a lot of problems related to domain, range, absolute maximum, minimum, function, one-to-one, and all these. Hope you will find it a good lecture and you can prepare it well. Thank you. Use the graph at the right to answer the following questions. Is g of x a function? Okay, सबसे पहले हमने देखना है if g of x is a function or not. So for the function we need to do the vertical line test, and vertical line test says us that I have to draw a vertical line anywhere and it should meet the point at one point. I will draw a vertical line here, it will meet the graph at the one point. Vertical line here, it will meet the graph at one point. Vertical line here, it will meet the graph at one point. So this function g of x passes vertical line test, so therefore yes, it is a function. Because it passes vertical line test. Now, is it 1 to 1? So we need to know that is it passes horizontal line test. So we know that it does not pass horizontal line test because it will draw a line over here, it crosses more than one point. So no, because it fails horizontal line test. Okay, state the domain of this graph. So what will be the domain of this graph? Domain is all the x values on the graph. So graph is going towards here, it is going towards negative infinity, and towards here it is going towards positive infinity. So the domain would be negative infinity to positive infinity. Range are all the y values. The graph is going downwards towards infinity, negative infinity, and to upwards it is stopping at 8, and 8 is not included. So from negative infinity to 8, where 8 is not included. State the interval g of x is increasing. Increasing means going upward, so it is going upward from here to here. This is the point where the graph g of x is decreasing. So first question is for decreasing, so it is decreasing from here to here. This is the line where it's decreasing, starting decreasing from -2, and it will from to 0, -2 to 0 union. It is decreasing from here to minus infinity, and this point is 2. So 2 is not included, to minus infinity. Sorry, this is the point and this is 3. Okay, state the interval g of x is increasing. This is about decreasing. Now we will state the interval where g of x is increasing. So for increasing we have 0 is included to this point is 3. So 0 to 3, and 3 is not included, 0 is included, and 3 is not included. Because in the interval g of x increasing decreasing, we're going to look the x-axis values. Okay, if the state the interval g of x is constant from here to negative infinity, -2 to negative infinity, and -2 is included. Relative maximum. Okay, what is the relative maximum? The maximum values. So is there any maximum value that exists? No, so it does not exist. What is relative minimum? The minimum value would be 0. Absolute minimum, any minimum which is absolute, no, does not exist because it's going to negative infinity. And absolute maximum, and absolute minimum also does not exist. Okay, the next question is g of 3. G of 3 is equal to, this is the close point 3. g of -10. -10 does not exist. G of -8, -9, -10, it is all going in the straight line, that is 1. G of 2 will be equal to 4. Where is g of x is equal to 3? G of x is equal to 3. At x is equal to 1.8, -1.8, and 3. 1.8, -1.8, and 3. Where is g of x greater than 0? Means g of x is greater than 0 means that is g of x is above the x-axis. So it's greater than 0 from -infinity to 0 and 0 to 3. Okay, what do these functions have in common? Which one doesn't belong? So let's find the domain first of all. But it will be the domain of the a because it's going over here and going over here, so it would be from positive infinity to negative infinity. That is real numbers. So we can see one other thing over here, that we have the symmetry. Okay, the a has, you can see that a has a symmetry along y-axis because the same thing over here and the same things along the y-axis. So a has symmetry along y-axis. B is again the same thing, symmetry along y-axis. C, symmetry along y-axis. D does not have symmetry along y-axis. E, yes, it do have symmetry. F. So A, B, C, E, F have symmetry along y-axis. Therefore D is different. Why do these functions have in common which do not belong? Okay, so 1 has a symmetry along the origin, 2 does not have symmetry along origin, 3 has symmetry along origin, 4 has symmetry along origin. No, 4 does not have symmetry along origin. Yes, 5 has symmetry and 6 has symmetry. So 1, 3, 5, 6 has symmetry along origin. So the answer for this is 2 and 4 are different. Okay, now coming to even and odd functions. If a function is symmetric with respect to the y-axis, it is even function and f of x is equal to f of minus x. If a function is, this is f of x, it is symmetric with respect to y-axis, that this is the y-axis. So the part of the function that is along this side is same along this side. It means if I have function x axis, this is x-axis and this is y-axis. So I have the same part of the function here and the same part of the function here. So if the function is symmetric along y-axis, then such a function is called even function. If a function is symmetric with respect to origin, it is an odd function. So this is an origin. The function is coming here in the origin and here in the origin. So it is symmetric along the origin, equal distance from the origin to the left side and the right side. Then this is called symmetric along, the function is odd. Most functions do not have any symmetry and are therefore neither even nor odd. Okay, use symmetry to decide if each of the following functions are even, odd, or neither. Okay, so if the function is going to have symmetry along the y-axis, it's going to be even. If the function is going to have symmetry along origin, it's going to be odd. Okay, so let's check. This is origin. It is going 1 and 1.5 box downwards, so it's going 1 and 1.5 box upwards. Then similarly it's going here and go here, so yes, it is symmetric along origin, so it's odd. Now this one, this is not is it symmetric? 1 2 and the third box has the line 1 2 and the third box has the line from bottom. The distances are equal on the both sides, so this is even because symmetric along y-axis. Now this is not symmetric along y-axis and neither with origin, so it is neither even nor odd. Okay, this is not symmetric along y-axis and neither about origin, so not neither symmetric. Okay, this is same along here and same here, even. This is origin, odd. This is same on the both sides, even. This is 1 2 1 2 3 4 and only 2 are in the bottom, so it is neither because the distances are not equal. This is 1 here, 1 here, even, or odd. Even means same, 1 box 1 2 1 2. But it is not symmetric along the y-axis, so neither. Okay, to verify algebraically whether a function f of x is even or odd, compute f of minus x and compare the results to the original f of x. A function is even if f of negative of x is equal to f of x for all values of x. A function is odd if f of negative of x is equal to minus f of x for all values of x, and f of negative of x is not equal to f of x or not equal to minus f of x, then the function is neither even nor odd. So we have already learned that if the function is even or odd by looking at the graph. Now we will learn algebraically. So f of x is equal to x cube minus 6x. So what will I do? I will put f of minus x, which is equal to minus x cube so f of negative x is not equal to f of x. When f of negative x is not equal to f of x, it means or we can just simplify it before giving the answer, minus x cube minus 6x. So f of negative of x is equal to minus, and this term is f of x. So f of negative of x is equal to minus f of x, so this function is odd. Okay, f of negative of x is equal to minus x to the power 4 plus 2 minus x square. So f of negative of x is equal to f of x. so it is even. Okay, we can write it 2 times. Okay, we have calculated f of negative x over here. So now let's compute f of x too. This is this. So f of negative of x is not equal to f of x. So this would be neither, even neither odd. F of negative of x would be equal to minus you can see that minus x square plus 6 is the value of f of x. So f of minus x is equal to f of x. It means it is even. So we have learned that how we can state if the function is even or odd using algebraic techniques and using graphical techniques. Okay. Coming to the problem set 1.2. Given the graph of f of x below left, sketch the graph of the following reflections. Okay, from where are the x values starting? X values are starting from 10. Okay, then x value is going to break at 2. Then this next break at minus 2. The next break is at minus 10, and there was 0 2. Okay, for 10 the y value is 4. For 2 it's 2. For negative 2 it's negative 2. For negative 10 it's negative 4. For 0 it's 0. This is the graph y is equal to f of x. Now in the part A we need to do reflection over the x-axis. So how we will reflect this graph over the x-axis? Whenever you have to do reflection over the x-axis, you have to use the ordered pair x negative 5. You have to put negative with the y. So the values of x will come as it is 10, 2, minus 2, 10, minus 10 and 0. But with the values of y you need to multiply minus. So it would be minus 4, minus 2, plus 2, plus 4, 0. So it's reflection over the x-axis. You need to multiply negative with the y. Let's plot 10 on the x-axis, minus 4 on the y-axis. 2 on the x-axis, minus 2 on the y-axis. Minus 2 on the x-axis, plus 2 on the y-axis. Minus 10 on the x-axis, plus 4 on the y-axis. And 0. So graph will look something like this. Okay, now we have to do the reflection over the y-axis. So for x-axis we need to multiply negative with y. So y-axis we need to multiply negative with x. So y values will come as such, and with x values we will multiply negative. Okay, now let's draw the graph. Negative 10 with positive 4, negative 2 with positive 2, plus 2 with negative 2, 10 with negative 4 and 0. So graph will look like this. The last is 180-degree rotation about the origin. So when we have to rotate about the origin, we need to multiply x and y both with the negative sign. So minus 10, minus 2, 2, 10, 0, minus 4, minus 2, 2, 4, 0. So negative 10 and negative 4, negative 4 and negative 2 and negative 2, plus 2 and plus 2, 10 and 4, 0. Okay, so it is the rotation along the origin. So what we have learned from this is, whenever we need to rotate the graph, reflect the graph along x-axis, multiply the y values with minus. When we have to reflect over y-axis, multiply the x values with minus, and about the origin, multiply both with the minus sign. How we to reflect the graph A to obtain the graph B in each case? Name the type of reflection. Okay, so this is very easy. This is the graph A and this is the graph B. So the type of the reflection is reflection along x-axis, and this is the reflection over y-axis. Okay. Verify algebraically whether each of the following functions is even order or neither. Okay, again the same one. I'm going to do it for f of negative of x. So f of minus x is not equal to f of x. So answer is neither. Okay, f of negative of x so f of negative of x is equal to f of x. This is if f of negative of x is equal to f of x, it's going to be even. Okay, if f of negative of x is equal to minus f of x, then it is called odd. F of negative of x is not equal to f of x, so neither. Okay, coming to question number 4. Uses the graph of g of x to answer the following questions. Is this a function or a relation? Okay, so function means it should pass a vertical line test. So it passes the vertical line test, so yes, it is a function. So why it is a function? How do you know? Because VLT passes. Is it 1 to 1? No, because HLT fails. What will be the domain? Domain will be all the x. So it's going from negative infinity to 3, which is not included, then union from negative 3, from -3 to positive infinity. Okay, range y values from -3 to the infinity. X-intercept, points crossing the x-axis. Y-intercept, points crossing the y-axis. 1, y is equal to 1. Okay, state the interval where g of x is increasing. Increasing mean going upwards. So this is from -4 to -3 because there is a uncolored point over here. So it's -4 including and excluding -3, union -3 to 2, and 2 is including, union. The next is going to start from increasing from 8 to infinity. State the interval where g of x is decreasing, means coming downwards. Two to 7. State the interval where g of x is constant from -4 to -infinity. Relative maximum. This is the relative maximum, that is 3. Relative minimum -2. Absolute maximum, because it's going to positive infinity, does not exist. Absolute minimum -3. G of 0 1. G of -3 does not exist. G of 2 3, where g of x is equal to 1. Zero and 8.3. G of x is less than equal to 0, means below x-axis. -infinity to -3, union -3 to -1, union 4 to 8. -infinity to -3, union -3 to 1, union 4 to 8. Use the graph below to answer the following questions. Okay, so domain of this graph, -2 to 7, 7 to then 8 to positive infinity, -2 to 7, 7 is not included, union 7 to positive infinity, range -8 to +8, x intercept, crossing at x intercept is 0, y intercept crossing at 0. Interval f of x is increasing, going upwards. -2 to 2, here the graph is increasing, then it's constant, and here it's decreasing, then it's increasing over here again from 8 to positive infinity. So -2 to 2 union 8 to positive infinity. F of x is decreasing, five to 7 union 7 to 8. State the interval f of x is constant, 2 to 5. F of x is greater than equal to 0, 0 to 7. F of x is equal to 8. Two to 5. The domain of this function is range of this function is x intercept y intercept, interval g of x is increasing from 3 to positive infinity, g of x is decreasing from -7 to -4, union 0 to 3. Interval g of x is constant from -4 to 0. Even, odd, or neither. For even, the function, by looking the graph we can tell that the graph is even or not, because the graph is not symmetric around the y-axis, so not even. not odd because not symmetric around the origin, so neither. 1 to 1, it cut us 2 points. No. HLD fails. Okay. So verify algebraically whether each of the following is even, odd, or neither. So f of minus 6, which is equal to minus 6, 4 minus x cube, minus 6, 4 minus x cube. So x4 minus x square, f of minus 6 would be equal to minus, this whole portion is f of x. Odd. This is f of negative x. Now let's compute minus f of x, which will be minus x minus x. So f of negative x is not equal to minus f of x, so neither. Okay, so we are done with this unit in which we have learned about the even and odd functions, and by looking at a function we can tell that either a function is even or odd. By doing the algebraic methods we can tell that whether a function is even or odd. Thank you. Consider the function y is equal to f of x graphed below. Reflect f of x over the x-axis. So that in the last worksheet and in the last video I have explained to you that how so in this worksheet we will do the warm-up. Consider the function y is equal to f of x graphed below. Reflect f of x over the x-axis. So how we are going to reflect the graph over the x-axis? This is what we have already done in our last video, and we have already learned that how to reflect the graph over the x-axis and over the y-axis. So to reflect the graph over the x-axis, we know that the x coordinates we will have x and negative y. To reflect over the x-axis, x values will remain same, but y coordinates will turn to their opposite signs. So whenever you need to reflect over x-axis, remember the one thing: x coordinate remain same, y coordinates turn to opposite signs. Okay, so very easy way to do is write x and y coordinates first. Okay, so what are the x coordinates? 2, 1, negative 1, negative 3, negative 5. What are the y coordinates? If it's 2, it's going to be 1, 2, 3. It's 1, it's going to be 0. Negative 1, it's going to be 4. Negative 3, it's going to be 4. Negative 5, it's going to be 1, 2, 3, negative 4. So what we have to do is change all the y coordinates: negative, 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 positive. Now Let's plot the graph according to this. Okay, so x is same, just change the y. 2 and -3, 1 2 3. 1 and 0 would be same. -1 and -4, 1 2 3 4. -4 here, and -5 and +4. Like this. So graph would be something like this. Okay, what is the equation for this new graph? So because the original equation was y is equal to f of x, so this equation is y is equal to negative of f of x. Okay, reflect the f(x) over the y-axis. So what we have to do is y will remain same and x will get the negative sign. So very easy, just write x and y coordinates. 1 2. So x is 2, then x is 1, then x is -1, here x is -2, -3, sorry, 4, and then -5. For x is 2, y is 3. For x is 1, y is 0. For -1 it's 4, for -3 it's 4, for -5 it's -4. Now we need to change the signs of x. Okay, so let's plot it. Okay, x is -2. Okay, -1, x is -2. X is -2 and y is +3. X is -1 and y is 0. Then x is +1 and y is 4. X is +3 and y is 4. X is +5 and y is 1 2 3 -4. So like this, we have this. So remember, whenever we have to reflect over x-axis, change the signs of y. Whenever we have to reflect over y-axis, change the sign of x. What is the equation for this new graph? Y is equal to f, and we're changing the sign of x, so negative of x. Here we're changing the sign of y, so y is equal to -f of x. Okay, in explorations below, consider how we could perform the solid back graph y is equal to f of x to the dotted one. In each section, looks for pattern. Use the following words to describe what you see: stretch horizontally or vertically, compress horizontally or vertically, translate up or down. Task 1. Exploring y is equal to f of x plus minus k. Describe in words how could you transform the solid graph so that it maps onto the dotted graph. We need to write the names. So it's f of x plus 4. So we need to do is, we need to shift this graph upwards by 4 units. F of x minus 3, we need to shift downwards or move down by 3 units. y is equal to f of x plus minus h. Describe in words. Okay, we need to f x plus 3. Okay, what is this? This is the function f of x. First we have the complete function and we're adding 4, so we need to move up by 4 or move down by 3, but here the only the x component is moving, x plus 3. So what we're going to do is move only along x-axis. So if we have to move only along x-axis, it means we can move either left or right. So move left 3, and x minus 4 move right 4. For negative, move right. For positive, move left. So when it's x plus 3, graph move towards left. When it's x minus 4, graph move towards right. So the intuition is opposite against intuition, because we need to think that if it's x plus 3, so it's positive side of the x-axis, but we need to go on to the left side. If it's x negative 4, it's negative side of the x-axis, but we need to go to the other side, so we have to do the opposite one. Okay, describe how the graph of f of x is transformed to create the graph of g of x in each case below, then write an equation for g of x in terms of f of x. So how it has transformed, let's see. The graph here, the point is 1 0, and the point over here, this point is 3 and 3 from the x-axis and 5 from the y-axis. So the graph of the x-axis moved from 1 to 3 and the y moved from 0 to 5. So for the x-axis it moves 2 unit right, and for y-axis it moves 5 unit up. So the equation would be g of x is equal to f of x move 2 unit right, f of x, if it's right we need to subtract x minus 2 and 5 unit up plus 5. Okay, now this one very easy. This is the point and this is moving 1 2 units downwards. X is moving, y is moving. Okay, so what is this point? X-axis it's minus 5 and minus 4, and this point is 0 from the x-axis and negative 6 from the y-axis. So for the x coordinate it's moving from minus 5 to 0, which moves, it's moving towards the right side, so it would be f of x minus 5. And for the y coordinate it's moving from minus 4 to minus 6. It means the difference of 2. It's moving downwards, so it would be minus 2. When we have to move downwards we have to subtract, when we have to move upwards we need to add. So g of x is equal to f of x minus 5 minus 2. Use the graph in the tables to help you decide how to transform the solid graph to the dotted graph. Okay, so for this is the solid graph and this is the dilated graph. So minus 5 minus 5 minus 3 minus 3 minus 1 1 2. So x remains the same. It means there is no change horizontally. Vertically it's minus 4 minus 8, so it's 2 into fx. So vertically it dilates by 2. If it is change in the y-axis, so it's going to vertically dilate by 2. If change in the y-axis, it means vertically it's moving. Now minus 5 minus 5 minus 3 3 minus 1 1 2 2. So x-axis same, y-axis is doing the half. So vertically it dilates by 1/2. Use the graph in the tables. You have to decide how to transform the solid graph to the dotted graph. Okay, again the same thing. Now horizontally dilate by 1/2. Okay, and here horizontally dilate by 2. Okay, so what does each person match what you expected to the transformation V? So if it is dilating horizontally, it's in the opposite direction. Like if it is negative, if it is 2 f of x, so it should move forward, but it's going backward. So horizontally it's going opposite. Vertically it is matching intentions. So what is happening that let's check over here that if the graph here is moving 2 units towards right along the x-axis, so if it's moving 2 units towards right along the x-axis, so we have to put the negative sign, but if it's moving 2 units towards left, we need to put the positive sign. Like it would be opposite as this, which is the equation for the new graph. So it's x negative of y, y is equal to minus f of x, and if it's moving horizontally, we could write f of is equal to minus x. Okay, again in this we have f of x minus 4. We have to subtract something from the x, but it's going towards left side. It's going towards right side. But if we have to add something in the x, it will go in the left side. So if you need to add in x, it's going to go on the left side. If you will subtract, it's going the right side. So it's going opposite to the intention. But vertically, it's going same as the intention says. If you're going to add 5 units, it will go upward. If you will subtract 5 units, it will go downward. Okay. Describe the transformation that would map the graph f of x onto the graph g of x 1/3 5 f of x. So 1/3 is y. So y will be, we need to compress f of x vertically f of x vertically by 1/3, and we are multiplying something by 5, so and horizontally by 1/5. The transformation equation accounts for all 3 different types of the transformations that can occur. Y is equal to a f b x plus h plus k. So if you need to reflect y is equal to negative f of x, reflect vertically over x-axis. So it's going to reflect vertically over x-axis. If f is equal to f minus x, reflects horizontally over y-axis. So if this is a graph and reflect vertically over x-axis, negative f of x, because if it's going to reflect, it's going to go like this upward, or it's going to come like this downward. Now this is for the first point. For the second point, reflect horizontally over y-axis, it will go like this horizontally. It will move horizontally in this direction. Next point is a f of x. A is greater than 0, compacts vertically. It will become like this. And if A is greater than 1, then expand vertically, like this. For B of x, expand horizontally and compacts horizontally. And for the last one, f of x plus k. Plus k means if k is greater than 0, it's going to translate up. If k is less than 0, it's going to translate down. If h is fx plus h, there is something adding with this x, then h is greater than 0, then translate left. And if h is less than 0, then translate towards the right. Opposite is going to happen over here. The point 2, negative 5 is on the graph of f of x. Find the coordinates of the corresponding point after f of x has undergone the following transformations. Now we are given with the function f of x, and function f of x has the point negative 2, 2 and negative 5. So we need to find the coordinates of the corresponding point of the same point after the f of x has done the following transformation. So negative of f, this negative means, let's understand this equation. This negative sign means to reflect over y-axis, over x-axis. This 3 means horizontally dilate by 1/3, and 4 means move, plus 4 moves left, negative 4 moves right, and this negative 2 means move down. Okay, how did we understand this equation? To understand this equation, we first need to understand this equation. And what is this equation? This means A means vertical reflection. Reflect over x-axis, and when we will reflect over x-axis, we will affect y values. What does this B means? Horizontal reflection. And when we will reflect horizontally, we will affect x values. Okay. What does this H means? Horizontal translation. And the last is also horizontal translation affect x values. And the last is vertical translation. It affects y values. So now whatever equation is given to us, we are going to compare it with this equation. Okay, let me do it again for you. Y is equal to A dot F B x plus H plus K. Okay, so what is A here? A is -1. What is B here? B is 3. What is H here? H is 4. What is k here? K is -2. Okay, so now according to the information that we learned, just A means vertical reflection. A means we need to affect vertical reflection simply. B means horizontal reflection. H means horizontal translation. And K means vertical translation. Okay. So coming back to our question, what we need to do is reflect x values with -1. So what was the x value? X value is 2 as given. So what we have to do is reflect x values by -1 means we need to change the y value. So we are not going to change anything over here with A. Now B is horizontal reflection means we need to change the x values. We have to put the negative sign with the x value. So if it is 3, so there will be horizontal reflection. So it's a horizontal reflection. We're going to affect x value, so it's multiplied by 1/3. We will get 2/3. Now horizontal translation, we are going to, if x plus h, it means it is if it's positive, we are need to subtract this. So -4 multiplied with -4, and that will give us -10/3. Okay, now y value. Y value is given as -5. Vertical reflection by -1. So it means we have to affect the y value over here. So we are going to multiply with -1. I will get +5. Horizontal reflection is 10. Horizontal translation is, vertical translation is -2, which I will get 3. So the new coordinates of xy would be -10/3 and 3. State the transformation that map g of x onto y is equal to 2g x plus 3. Okay. So if we match with our current equation, that is y is equal to a dot f b x plus h plus k. So it's 2g. It means a is equal to 2g, and there is no b given. X plus 3, which means h is equal to 3. So there are two things. A is equal to 3. Vertical reflection is reflect vertically by 2. Translate horizontally by 3. I can write it over here. A is equal to 2, h is equal to 3 for this part here. Okay, sketch the graph y is equal to 2g x plus 3. So x y में what changes that we have to encounter in xy. X is going to, we need to reflect vertically by 2, so it's going to affect the y values, and y would be 2y. Translate horizontally by 3, so it's going to be x minus 3. Okay, so the x values are 0, 1, 2, -1, -2. Y are 0, 1 and 1, 2 and 4, -1 and 1, -2 and +4. So when we are going to change this, it will become x minus 3, so 0 minus 3 minus 3, 1 minus 3 is -2, 2 minus 3 is -1, -1 minus 3 is -4, -2 minus 3 is -5. These are the x values and y values. 2 times 0 is 0, 2 1s are 2, 2 4s are 8, 2 1s are 2. These will be x and y values. -5, 8. Okay, so these will be the values of the new graph, and let's plot the graph according to these values. Okay, so x would be -3, 0, 1, and y would be 0. X would be -2 and y would be +2. X would be -1 and y would be 8. X would be -4 and y would be +2. -5 and 8. This will be the new graph. The graph f of x undergoes several transformations to create the graph g of x. Does g of x has the same shades as f of x? If not, what dilations must occur? So the graph f of x has this shape, and the graph g of x has this shape. So does they have same shapes? No. What dilations may occur? So this graph is starting from here, 1 2 3 4 5 6 7 and 8, and this graph is starting from here, 1 2 3 4 5 6 7 8 9 10 11 12. So it is 12 boxes long and it's 8 boxes long. So it is vertically dilated by 12 by 8, which is equal to 3 by 2. Does g of x have the same directions as f of x? If not, what reflections must occur? Reflections, it is reflected over y-axis. Okay. How would the graph of f of x look after the dilations and reflections you observed above? Sketch the new graph. Okay, so step 1 would be reflect over. Reflect over y-axis means change the signs of the x-axis values, and then dilate means vertically by 3.2, that is 1.5. What translations might happen now to move your sketch part from part C onto G or X? So g of x would be equal to 3 by 2 f of negative of x plus 1. Okay, the point minus 3, 7 is on the graph of f of x. Find the coordinates of the corresponding point after the following transformations. So we have also already learned how to do the transformations. The the point of the x-axis is minus 3. So what transformations is it undergoing? So first of all, we need to find out the values of our statement, and that would be y is equal to a f b x plus h plus k. According to this, 5 is equal to 5. According to this, x plus h means h is equal to 2 and k means k is equal to 1. So x is minus Okay. Consider the function g of x is equal to 1 by 3 f minus x plus 5 plus 4. Describe the transformations in the correct order that map the graph f of x onto g of x. So the first translation is, number one is, okay, dilate vertically by 1 by 3. Number two option is reflect over x-axis or y-axis. Reflect over y-axis. Then plus 5 means move left by 5. Plus 4 means move up by 4. If minus 4, 6 is a point to the graph f of x, what will be the corresponding point on g of x? So for x-axis, it would be minus 4. Reflect over y-axis means changes in the x values. So changes in the x values by minus 1. So minus 1, which becomes plus 4. Then move left by 5 means minus 5 becomes minus 1. Y is dilate vertically by 1 by 3, so it was 6 multiplied by 1 by 3 is 2. Move left, move up by 4, so it's plus 4, which is 6. So the new point is minus 1, 6. The graph of f of x is transformed according to the information below. Write an equation for each new graph in terms of f of x. Justify each response. F of x is transformed without using any reflections or dilations. So there is a maximum of minus 2, 0. Okay. Maximum at 0, 4. So the maximum is at 0, 4, and they are saying that maximum is at minus 2, 0. So this means we have gone down by 4 and left by 2. Y is equal to f of x plus 2 minus 4. F of x undergoes three transformations. So it is the domain of the new function minus 4, and the range is minus 6, 2. So domain is, domain would be, the domain of new function is minus 4, 4, and the range of new function is minus 6, 2. So it horizontally compresses by 1 by 2. So it's going to be minus 8, 8. It's going down by 2, minus 4, 4. Use the graph below to answer the following questions. For what value of x is f of x greater than equal to 0? This is the function f of x. For what values of x it is greater than equal to 0? From minus 2.5 to positive minus infinity. Union. Greater than equal to 0 means above x-axis. From 1.5 to 7.5. For what values of x is f of x greater than equal to g of x? y values on f of x is higher than the y values on g of x. So y values on f of x is higher from the point this, which is the point -2, minus infinity to -2. The f of x is higher than g of x, and from here 3 to 8. For what values of x is f of x less than g of x? Y values on f of x lower than y values on g of x. From -2 to 3, this portion. H to infinity. Operations with functions. Okay. If you are given any two functions, you can add, subtract, multiply, or divide those functions just as you would expect. Be sure to follow the order of operations PANDIAS and simplify as much as possible by combining the like terms. So 3x plus 5x is going to be 8x minus 2x, which is equal to 6x. 2x square minus 6x. 3x plus 4 times 3 is 12 minus 5. 3x plus 7. X plus 2 whole square is going to be x plus 2 x plus 2, which is equal to x square plus 2x plus 2x plus 4, which is equal to x square plus 4x plus 4. 2x square 10x minus x minus 5. 2x square 9x minus 5. So this is, we have performed the operations and combined the like terms. Observe the two functions machines below. X, f of x, f of x. So find f of 2. So f of 2 would be 2 into 2 minus 1. This is the f of x. So f of 2, we have to put 2 in this equation. It would be 4 minus 1, which is equal to 3. G of 2 means we need to put the values in this equation. 2 square plus 3, 4 plus 3, which is equal to 7. Now let's you say input the value x is equal to minus 3 into the function machine for f of x. X is equal to minus 3 in f of x, which will be equal to 2 minus 3 minus 1 minus 6 minus 1 minus 7. Now take output for f of minus 3 and use that as the input for the function. Now we get the output as minus 7. We need to put it in the g of x as the input. Minus 7 square plus 3, 49 plus 3, 52. Okay, function composition. Function composition is an operation whereby the output of one function becomes the input of the second function. As we have done this, the output of the function f of x has become the input for the function g of x. We often describe the function composition as substitution. F of g of x is equal to f g of x, substitute g of x. If it's f g of x, substitute g of x into the function f. If it's g f of x, substitute f of x in the function g. So we have f of x and g of x. Okay. So we have f of x and g of x. We need to find f g of 3. First of all, we need to find g of f g of x means we need to substitute g of x into f of x. Okay. So let's find g of 3 first. We get 2. Now we need to substitute 2 in f of 2, which will be equal to f of x and g of x is x square. So f o g x. F o g x means f g of x. So f g of x means we need to plug the value of g of x. Here g of x is x square. Now it's fx square. So we need to plug the value of we need to treat this x as x square. So this substitute x with x square and solve it. So, okay, so it's going to be x minus 3 means x square minus 3. Substitute x with x square. So answer we get is x square minus 3. Now if it's g of x, then it would be g f of x. So what we will do, we will put g over here and put f of x, x minus 3 over here. Now this is called x minus 3 is basically x. So g of x is equal to x square. So what is x here? X minus 3. So I will put x minus 3 square. X minus 3 square or x square minus 6x plus 9 would be the answer. Are the equations for f for gx and f g o f x same? No. Order matters. Consider the function f of x and g of x. Evaluate g f of minus 1. So it would be g f of minus 1, which will be equal to g. What about f of minus 1? 3 minus 1 minus 1. G minus 3 minus 1. G minus 4. So g minus 4 is equal to, put minus 4 here, minus 4 square plus 2 minus 4 plus 5. 16 minus 8 plus 5. 8 plus 5, 13. Okay, f of g of minus 1, very easy. Just put f of g of minus 1, like put minus 1 in g, x square plus 2x plus 5. So we will put minus 1 square plus 2 minus 1 plus 5. Okay, now let's solve it. F of minus 1 square is 1 minus 2 plus 5. F of 1 minus 2 minus 1 plus 5. F of 4. Now f of 4 would be equal to 3 into 4, because we need to put 4 in the function f of x. So f of x is 3x minus 1. So we will put 4 over here. 3 into 4 minus 1, which will be equal to 12 minus 1, 11. Did you get the same answer for g f of minus 1 and f g of minus 1? No. Order matters. Find the equation for g f of x. Now we need to find the equation for, very easy, g f of x. First of all, what we need to do, put g as it is. Put the equation of f of x over here. What is f of x? 3x minus 1. Now what is your x? Your x is changed. X is not x. X is now equal to 3x minus 1. So instead of x, you are going to put 3x minus 1. So what is g of x? G of x is x square. But instead of x, you will put 3x minus 1 square plus 2 3x minus 1 plus 5. So this is your equation for g of x. So let's open it. It's a minus b whole square so it's going to be a square plus b square minus 2ab plus 6x minus 2 plus 5. 9x square plus 1 minus 6x plus 6x minus 2 plus 5. 9x square, 5, 6 minus 2, 7. So it's 6 minus 2, 4. Okay, now find the equation for f g of x. So very easy for f g of x. First of all, we will write f as it is and write the equation of g of x. G of x is x square plus 2x plus 5. Now the new x is equal to x square plus 2x plus 5. So what is f of x? F of x is equal to 3 into x. 3 into x. And what is new x? X square plus 2x plus 5 minus 1. 3x square plus 6x plus 15 minus 1. 3x square plus 6x plus 14, which is the answer for part E. The point, this is on the graph f of x. Find the coordinates of the corresponding point after the following transformations of f of x. So the point minus 3, 7 is on the graph. Point is minus 3, 7 on the graph. So first of all, it's going to be do by 1 by 2 into y, because these values affect y. So it will become minus 3, 7 by 2. Then it's minus 4, so it would be x plus 4. So minus 3 plus 4 would be 1, 7 by 2. And then it's going to be plus 2 in the y-axis, 2 plus y. So it's going to be 1 and 5.5. Okay. So minus 3, 7. First of all, there is no change in the y-axis. And it's multiplying with x, so there will be a change in 1 by 2 x. So it will become minus 3 by 2, 7, which will be minus 4. So y minus 4 minus 3 by 2, 3. So it's minus 3, 7. It's going to be minus y. 3x Given the graph of f of x, sketch each transformation on the same grid. A table of values is optional. Y is equal to this f of, okay, x is 5, y is 2, x is 2, y is negative 2, x is negative 1, y is 4, x is negative 3, y is 4, x is negative 5, y is negative 4. And the transformation says to us that x minus 2 means x plus 2 and plus 3 means y plus 3. So the next would be x plus 2, y plus 3. So it will give us 5 plus 2, 7, 2 plus 2, 4, minus 1 plus 2, 1, minus 3 plus 2, minus 1, minus 5 plus 2, minus 3. 2 plus 3, 5, minus 2 plus 3, 1, 4 plus 3, 7, 4 plus 3, 7, minus 4 plus 3, minus 1. Okay, so the new graph would be 7 and 5. 4 and 1, 1 and 7, minus 1 and 7, minus 3 and minus 1. Y is equal to f of minus 1 by 2 x minus 3. So now the values of x and y would be, x is 5 and y is 2, x is 2 and y is minus 2, x is negative 1 and y is 4, negative 3 and y is 4, negative 5 and y is 6. So minus 1 by 2 x means minus 2x and y minus 3. So minus 10, minus 4, 2, 6, 10. Y minus 3, 2 minus 3 minus 1, minus 2 minus 3 minus 5, 4 minus 3 1, 4 minus 3 1, 6 minus 3 3. Okay, so minus 10 minus 10 and 1 minus 4 and minus 5, 2 and 1, 6 and 1, 10 and minus 7. Describe the transformations that correct ordered map f of x onto each of the following. So minus means here reflect over x, plus 3 means move 3 left. 1 by 4 means dilate by vertically, dilate by 1 by 4 and down 2. Reflect over y, dilate by 1 by 3 and move up 5. Use the table values for the f of x and g of x below to evaluate the following. F of 0 minus 2, g of 1 Okay, so f of 0, so putting f and x value of x is 0, so answer would be 1. G of 1, putting value of 1 in g, so answer would be 2. G of minus 1, putting the value of g minus 1 is 3, so I will get f of 3. Now putting 3 in f, I will get 4. F or gx, f g of 4. So f g of 4 minus 2, f minus 2, 0. G f minus 2, g f minus 2, 0. G of 0. Is there any value of x with g of 0? Does not exist. F g of 1, g of 1, 2, f of 2 does not exist. G f of 7, f of 7 answer is 6. G of 6 answer is minus 4. F g of 6, f g of 6 answer is minus 4. F of minus 4 does not exist. G f of 0, 1. G of 1, 2. So in this way we can solve the questions by using the table values. Given the information, given the function f of x and g of x, evaluate and simplify f or gx. So it's very simple. F g of x. So you need to write over here g of x, that is 3x plus 1. This is g of x. Now this x is equal to 3x plus 1. So write it in f of x equal to 1 by 3. X, what is x? 3x plus 1 minus 3. So x plus 1 by 3 minus 3. g f of x. So g, what is f of x? 1 by 3x minus 3. So now the new x is equal to 1 by 3x minus 3. This has become the new x. So now g of x is equal to 3 into x. So what is the value of x? 1 by 3x minus 3 plus 1. Given f of x, this, g of x, this, z of x, this, evaluate and simplify. F g of x. G of x is x square minus 25. So f of x is, now x is equal to x square minus 25. The new x is this. So f of x is 5 minus x. What is x? X square minus 25. Minus x square plus 30. G f of x. G, what is f of x? 5 minus x. Now the new x is 5 minus x. So g of x is x square minus 25. So putting 5 minus x square minus 25. 25 plus x square minus 2ab minus 25. X square minus 10x. G h of x. G h of minus 2. So putting the value minus 2 in h. 3 minus 2 minus 2. Minus 6 minus 2. G of minus 8. Now putting minus 8 in g. Minus 8 square minus 25. 64 minus 25. 39. Now it's h g f1. So putting 1 in f. 5 minus 1. h g4. So now 8. What about g4? 4 times 4 is 4 square minus 25. h 16 minus 25. h minus 9. Now putting minus 9 in h. 3 into minus 9 minus 2. Consider the graph of the following function f of x to the right, state the domain. So what is the domain? Domain are the x values. So graph is starting from minus infinity and going from to stop at minus 4. Then union from minus 4 to positive infinity, because this point isn't included. So minus infinity to minus 4, union minus 4 to positive infinity. Range are the y values of the graph. So graph is starting from minus 2, which is not included, going to negative infinity from here. So negative infinity to, it's above going 6. So negative infinity to 6. Where is f of x is equal to 4? Y value is 4 at minus 1. Minus 5, minus 1, 0.8, 3.7. F of 2, f of 2, there is no point because here it is unfilled box and does not exist. F of 4, it is -1. Let me check it again. F of 2. For f of 2, the point is unfilled. So for f of 4, it's -1. List any absolute minima. Absolute relative minima would be -1. Absolute maxima would be 6 because going maximum to the 6 from the y-axis, and relative maximum would be 5 and then 4. F of x is increasing. It's increasing from -infinity to -5. So it's going from -infinity to -5, which is included union -4 to 0, union 2 to 2.5. FOF2 means f of 2, which is equal to f at 2 is equal to y value is 2, then is equal to -1. So f of -1 is equal to point. F of 2 does not exist, so it's not going to exist. If f of x is reflected over x-axis stretched vertically by a factor of 3, stretched vertically by a factor of 3, complex horizontally by a factor of 1/2, and shifted down towards 1. So we are done with this worksheet. So in this topic, we're going to study about the inverse functions. The opposite of square is square rooting. If we need to take the square of a function, square of a number, like 2 square, so the opposite of it is square root of 2. If we need to, opposite of multiplying is by 2 multiplied by 2 is 4. So 4 divided by 2 is 2. When you find the opposite of operation in order to undo a function, you are finding its inverse. So we are going to study about the inverse function. Let's do a warm-up. Okay, think of a number. Let's suppose I think of the number 8. Subtract 3, I will get 5. Now I will add 3, I will again get 8. So f of x is equal to x plus 3, g of x is equal to x minus 3. Are inverse functions. They undo each other. If f of x is x plus 3 and g of x is x minus 3, graph the linear functions f of x and g of x on the same grid. Use the slope and the y-intercept or a table of values to help you out. So the function f of x is x plus 3. So function y is equal to x or f of x is equal to x is this. So x plus 3 would be 3 lines upwards. 1, 2, 3. This will be the function f of x, and g of x would be 1, 2, 3 downwards. This would be g of x. Okay, what do you notice about these graphs? These graphs are a reflection of each other over the line y is equal to x. Reflection of each other over y is equal to x. Okay, consider a function machine that takes an input value, doubles it, and subtracts 5 and sends out the result. Write an equation for this and put it inside the function machine. Okay, so what is the function machine doing? Function machine, consider function machine that takes an input values. Let's suppose it takes an input values x, doubles it, subtract 5 and sends the results out, and the this would be the output of f of x. So the function machine either has the equation f of x is equal to 2x minus 5. Find the result when the input value is 3. So if we will put the input value 3, it would be 3 times 2 is 6 minus 5 is 1. So the answer would be 1. How could you change this result back into the input value 3? What operations would you perform and in what order? Can you write an equation for the inverse function? So for the inverse function, what we're going to do is 1 plus 5, which is going to be 6, and 6 divided by 2, which is going to be 3. So, or we can do it like this. For the reverse function, we're starting with 1. So we're going to add 5 and 1, we will get 6. So we will divide 6 by 2, we will get 3, which is the output, and this is the input. So can you write the equation of the inverse function? The equation of the inverse function will be 1. What is when? This would be x plus 5 divided by 2. This would be g of x, the other function, the inverse function. If f of x was the function and g of x is the inverse function. So f of x is 2x minus 5, g of x is x plus 5 by 2. Find f g of x. To find f g of x, f, what is g of x? X plus 5 by 2. So now the new x is x plus 5 by 2. So it's f of x. So what is f of x? 2 x minus 5. So it's x plus 5 minus 5, which is equal to x. Okay. So now compute g f of x. Okay. G, what is f of x? 2x minus 5. So now the new x is equal to 2x minus 5. So it's g of x. It's g of x, and g of x is x plus 5. What is x? 2x minus 5 plus 5 divided by 2. So what do you notice? That f g of x is equal to g f of x. Okay. Properties of inverse. If the inverse is a function, then we use the notation f inverse x to denote the inverse. If a given function f of x is 1 to 1, then its inverse will also be a function. The graphs of inverse functions are reflective over the line y is equal to x. The graphs of inverse functions are reflective over y is equal to x. Okay. And if a given function f of x is 1 to 1, then in inverse will also be a function. If x and y are coordinates of the original function f of x, so we have to get the graph of the inverse function f inverse x. Okay. Consider the set of the points. Plot the set points on the grid provided. Okay. 4 minus 3. 4, 1, 2, negative 3. 2, negative 1, 2, negative 1. 7, 0, 7, 0. Minus 1, 4. 2, 10. Okay. So these are the set of points that I have plotted on the graph. So what is the domain of this set of points? So we have already learned about the domains. The first elements are called the domains. All the first elements are domains. So it's going to be 4, 2, 7, minus 1. Again it is 2, so we can write it one time. What is the range of the set? The second elements are called range. Switch x and y to write the inverse set. So let's write the inverse set. Minus 3, 4. So if it is 4 minus 3, switch like this. Okay. Minus 1, 2, 0, 7, 4, negative 1, 10, 2. State the domain of the inverse function. Now the domain would be minus 3, minus 1, 0, 4, 10. And the range would be 4, 2, 7, minus 1. Do you notice it? What do you notice about the domain and the range of the inverse functions? The domain of the original set becomes the range of the new set, and the range of the original set becomes the domain of the new sets. Domain of original is equal to range of new set. Range of original becomes the domain of new set. Consider the relation graphed below. Just this graph represents a function. For a function, we need to do the vertical line test. And what was the vertical line test? We need to put out a vertical line. It should cut the graph only at 1 point. So yes, vertical line test passes. Is it one-to-one function? For one-to-one function, what you need to do is put a horizontal line, and it should pass to, if it's passing more than 1 point, so no, horizontal line test fails. Okay, so because we're going to we are doing the revision, so you already have watched all of my previous videos in which we have learned in detail that what is vertical line test, what is horizontal line test, and you already know that what we're working for. Okay, so x and y, sketch the inverse function on the same grid of x and y. So for the inverse function, what we're going to do is put the x values, y values for the x, and x values for the y. Okay, now let's plot 3 and minus 9. 1 2 3 and 2 3 4 5 6 7 8 minus 9. 7 4 5 6 7 and minus 7. Minus 3 and minus 3. Minus 3 and 2, 3 and 8. So the inverse function is this, 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 this. Is the inverse relation also a function? So about the inverse relation, it's not a function, because if we will draw a line here, it touches vertical line test is failed over here, so it's no, vertical line test failed. Consider the relation below. Consider the relation graphed below. Just this graph represents a function. Okay, so vertical line test, yes, the vertical line test passed, so yes, VLT passes. Okay, so is this graph one-to-one function? So I think yes, it is passing horizontal line test. Sketch the graph of inverse on the same grid. So to sketch the graph of the inverse on the same grid, what you need to do first of all is you need to get all the y and the x values opposite. Okay, if it's 4 and 4, so the opposite would be again 4 and 4. It's the same point. It's 0 and 3, so opposite would be 3 and 0, so it would be 1 2 3 and 0. Minus 1 and 1, it would be 1 and minus 1, so it would be 1 and minus 1. Minus 3 and 0 would be 3, 0 and minus 3 would be 0 and 1 2 minus 3. Minus 4 minus 2 would be minus 2 minus 4, it would be minus 2 minus 4. Okay, so this is the graph. It's an inverse relation of function. So yes, the inverse relation is a function too, because it passes a vertical line test. How does this compare to the last problem? The original function of the present question is not one-to-one, but the other one is one-to-one. finding the equation of an inverse algebraically. Oftentimes, we can find the equation for the inverse by reversing the operations of the original function. Sometimes it's not so obvious and we need to algebraic approach to find the equation of the inverse. So first of all, how to find the inverse is switch x and y and then solve for y. So f of x is equal to 2x minus 1. So we will write y is equal to 2x minus 1, then switch x and y will become x is equal to 2y minus 1, and then solve for y. This is the inverse of this function. So very easy. Whenever you need to find the inverse, what you have to do is switch x and y and then solve for y. Okay, part B is g of x. So let's write it y is equal to minus 2 x minus 5 over 6. Switch x and y. We will get x is equal to minus 2 y minus 5 over 6. It will be 6x minus 2y plus 10. 6x minus 10 is equal to minus 2y. 6x minus 10 over minus 2, which is equal to y. So this was the, we can just write it 3x minus 5 over minus 2 is equal to y, which can be equal to minus 3x plus 5. So I'm writing over here g inverse of x is equal to minus 3x plus 5. Okay, so write y is equal to f of x. Okay, y is equal to 1 by 3x plus 2. Switch, put y कीजिएगा x and in replacement of x put y. Now solve for y. Now why I'm writing f inverse x over here instead of y? Because I'm just solving it here. We're writing f of x is equal to y, so x is going to be equal to f inverse okay. So it's y is equal to minus 2x plus 4. Now switch, put x is equal to minus 2y plus 4. Here I have switch. So I will write x minus 4 divided by minus 2, which is equal to y. So f inverse of x is equal to minus x minus 4 by 2. Extension. Proving functions are inverses. If two functions are inverses, then they will undo one another. As we saw earlier, f of x is equal to x plus 3 and g of x is equal to x minus the inverse of each other. This means that g of x will undo whatever f of x does an input value. Let's try with x is equal to 2. So the first question here we have 2. So 2 plus 3 is going to give us 5. Now undo it. We will take 5 minus 3 is going to again give us 2. So g of f of 2, g of function, in function f we put 2, and in function g f of 2 we will get the answer 2. So 2 minus 3 is minus 1, here minus 1, minus 1 plus 3 is plus 2. So g of 2 will result in fg of 2. It is a proof of f of x and g of x are inverses. What about when x is equal to 0 or x is equal to square root 3? Simply, we cannot possibly tell the input values to verify two functions are inverses for all values of x. We will prove that the inverse are more generally using x as an input. So this is where function composition comes in handy. F of x is equal to g of x is. So compute f or g or x, which can be equal to f g of x, which can be equal to f g of x is x minus 3, which can be equal to f of x, and f of x would be x plus 3, x plus 3, which is equal to x. G f of x, which is equal to g, and what is f of x? X plus 3, and g of x is x plus 3, which is equal to x. So f f f of g x and f g of x and g f of x are inverses for one another, so because both get the answer x. Okay, if we are asked to prove or verify inverses algebraically, use the following theorem: f g of x is equal to x and g f of x is equal to x, and f of x and g of x are inverses. If both will get the same answer, it means they are inverses. If f g of x and g f of x both get the same answer, it means they are. So use function composition to verify whether these are inverses or not. So to verify, first of all, we will find out f g of x, which is equal to f, what is g of x? 3x minus 2. So f of x, what is f of x? 1 over 3 x. What is x? 3x minus 2 plus 2. So it's going to be x minus 2 by 3 plus 2. Okay, now it was f g of x. Now we will find g f of x, which is equal to g 1 by 3x plus 2, which is equal to 3 x is 1 by 3x plus 2 minus 2, x plus 2 by 3 minus 2, 1 3 is 3. So they are not equal, so f of x and g of x are not inverses. Okay, now f g of x, which is equal to f minus 1 by 2x plus 2, f of x minus 2 minus 1 by 2x plus 2 plus 4, minus minus plus, and it would be x minus 2 times 2 is 4 and 4, so we get x over here. So now g f of x, g minus 2x plus 4, and g of x is equal to minus 1 by 2 x plus 2 x minus 2 plus 2, which is equal to x. So here f of x and g of x are inverses. At right is a picture of Anita's function machine. When she put 3 into the machine put out a 7. When she put a 4, machine gives her a 9. When she put minus 3, she comes up with minus 5. So what is happening? When she put 3, she gets out the machine is 7. So 3, it was adding, when she was putting 3, she was getting 7. When she was putting 4, machine gives her 9. When she put minus 3, machine gives her minus 5. So what's happening? 3 times 3 is 9. 3 times 2 is 6 plus 1 7. So it can be 2x plus 1 is equal to y. 2 times 3 is 6 plus 1 7. 4 times 2 is 8 plus 1 9. Minus 3 times 2 is minus 6 plus 1 minus 5. Suppose it were possible to turn the crack in the opposite direction, causing the machine to pull out the outputs back up and undo the effect of the first function machine. That is what she wants: a machine that will take 7 and turn and back to 3, take 90, turn it back to 4, and so on. Writing the rule, what program should the new machine do is y is equal to 2x plus 1 was the first machine. So switch x and y to y plus 1. Solve for y. So the new machine will do this thing. Find the inverse for each of the function, for each of the relation. Okay. Just do the opposite. 3 1, 3 minus 2, 1 5, 4 6. For each function below, sketch a graph of the inverse on the same grid. Can you see the reflection in the line y is equal to x? Okay. So the point, this point is 3 minus 2. This is 0 minus 3. This is 4 3 6 1. So the inverse would be 3 minus 2, inverse would be minus 2 3. Zero minus 3 would be minus 3 0, 3 4, and 1 6. I'm going to plot it again. Okay. Minus 2 3 1 2 minus 2, positive 3 1 2 3, minus 3 0, 3 minus 4, 1 minus 6. One, it would be 0 1 on the x-axis and 0 on the y-axis. 2 1, 5 2, 10 3. So opposite will be 0 1, 0 on the x-axis and 1 on the y-axis. 2 1, 1 2, 1 2 5, 3 10. For each of the following functions, f of x is equal to 3x minus 5, state the domain of f of x. So domain are the values which we can input on the f of x, so we can put any value of x. So it would be minus infinity to plus infinity, and the range would be any output we can get, so minus infinity to. Graph f inverse x on the same grid. So first of all we need to graph f of x, and then we will graph f of inverse x. So here we will write the values of x and y coordinates. For x is 1, 3 ones are 3, minus 5 is equal to minus 2, 2, 6 minus 5 is equal to 1, 3, 9 minus 5 is equal to 4, minus 1, minus 3 minus 5 is equal to minus 8, minus 2, minus 6 minus 5 is equal to 3 into minus 2 minus 6 minus 5 would be minus 11. Okay, so let's plot this first. X is 1 and y is negative 2. X is 2 and y is 1. X is 3 and y is 4. X is negative 1 and y is negative 8. X is negative 2 and y is negative 11. So it's something going on like this. This is f of x. What will happen to f inverse x? For f inverse x, we will have x and y opposite, minus 2, 1, 4, minus 8, 1, 2, 3, minus 1. So minus 2 and 1, 1 and 2, 4 and 3, minus 8, it's going to be something like this, f inverse x. State the domain of f inverse x. So f inverse x also moving from minus infinity to plus infinity, and the range will be again from minus infinity to plus infinity. Graph g of x is equal to 1 by 3x plus 4. State the domain. So 1 by 3x plus 4 can be graphed as one by 3 plus 4. 4.3, 2 by 3 plus 4, 4.604, minus 1, minus 1 by 3 plus 4, minus 1 by 3 plus 12 by 3, 11 by 3, and 9, 3.6, and minus 2 by 3 plus 12 by 3, 10 by 3, 2.3. Okay, so it's going to be 1, 4.3, 2, 4.6, 0, 4, minus 1 3.6, minus 2 2.3, this is the graph of g of x. So domain would be minus infinity to plus infinity, and range would be minus infinity to plus infinity. Graph g inverse x on the same grid. So doing the opposite, 4.3, 4.6, 4, 3.6, 2.3, and it goes with 1 2 0 negative 1 negative 2. 4.3 and 1, 4.6 and 2, 4 and 0, 3.6 and negative 1, 2.3 and negative 2. This would be something like this. So the domain and the range. If we can plot the points more carefully, it can be 4.3 and 1, 4.6 and 2, 4 and 0, 3.6 and negative 1, 2.3 and negative 2. Okay, so domain and range would be minus infinity to plus infinity. Write the equation of g inverse x. So g inverse x is, g of x is 1 by 3x plus 4, so our g inverse x would be y is equal to 1 by 3x plus 4. Switching, x is equal to 1 by 3y plus 4, x minus 4 multiplied by 3 is equal to y. So g inverse of x would be equal to 3x minus 4. Algebraically determine the equation of the inverse of each of the following. So we need to find the inverse. Okay, so the first step is switch. If it's f of x, you can write y instead of f of x. Then you can switch. Now switch. Now solve for y. Switch. Extension. Use function composition to verify whether or not each of the following pairs of the function are inverses. So f of x, we need to find f g of x and g f of x, and if we will get the x, it means they are, otherwise they're not. So we need to find f g of x. it's become f of x. Now f of x is 3. Not equal to x, so f of x and g of x are not inverse. This is x now, so x plus 1. This is x now, so g of x is 2 x minus 1. So f of x and g of x are inverses. Spot the error, identify the incorrect algebra in the following problem. Use function composition to verify whether or each of the following pairs are inverses or not. So f of x and g of f, g of x. Let's find the f, g of x ourselves, and then we can indicate the problem too. Now this is x, so we need to put over here 2 by 3 x minus 8. Okay. So f g of x is giving us x. Now we need to calculate g f of x. What is f of x? 2 by 3 x minus 8. So now this is x, 2x, gx. 3 by 2 x plus 8. 3 by 2 x plus 8. So solving it is 2233x minus 24 by 2 . 3 by 2 x, 2 by 3 x minus 8 x plus 8. So x plus 8 was a function to be performed first, because it is like this, x plus 8. So f g of x is equal to x, and g f of x is equal to x, so yes, inverses. So now we are going to revise all the problems that we have learned in the function theory. Use the graph to answer the following questions, state the domain. So we know domain are the x values. Okay, so the domain is starting from -5 and the point is included. Moving towards 1, 2 and 3, the point is not included, and then 3 towards positive infinity. Range is the y values. Y values is starting from -infinity and going maximum to 6. F of -3 means we have to look -3 in the x-axis. -3 in the x-axis. So the answer with the y values is 6. F of x is equal to 3 means look 3 in the y-axis. These 2 points are not included, so this point is included, which is giving the answer 5. f of 0 means look 0 on the x-axis, y is also 0. Identify any maxima. Maxima is the maximum point on the x-axis. So the graph is going maximum over here, which is 4. Minima is the maximum point of the y-axis. So y-axis, the negative portion is 0, so it would be 0. F of x is 0. F of x is 0 means y is 0. So y is 0 means y is 0. F of x is equal to 0 means on 0 and 6. X is equal to 0 and 6. Because here it's 0, 0 and here it's 6. So y is 0 at both these points. F of x is increasing. Okay. Now f of x is from here to here. From 0 including to 3 excluding union 3 to 4. Decreasing from here to here -1 -2 to 0. Union 0 to 3 union 3 to 6. F of x is constant from -5 to -2. F of x is greater than 0 means above x-axis is -5 to 0. Union 0 to 6. And 3 is not included, so 3 union 3 to 6. Determine from the graph whether each of the following function is even, odd or neither. So we have already learned how to check the function is even or odd or neither. So for checking the function is even, we need to find out f of -6, which is equal to minus x square plus 10, which is equal to minus x square plus 10. So f of x is equal to f of -6, so it is even function. Now f of -x would be equal to 1 minus x minus x cube, which is equal to 1 plus x minus x cube is minus x cube, which is equal to plus x cube. So f of x is not equal to f of -x. Second option is we need to check f minus f of x, which is equal to -1 minus x minus x cube. So -1 plus x cube. So f of x is not equal to minus f of x, so it would be neither, not even or odd. Calculate the graph of f of x on the right, perform the following reflections. Table of values is optional. Consider graph f of x on the right, can perform the following reflections. Okay, we need to do the following reflections. So very easy. First of all, let's plot the values. X is -8 and y is -3. X is -5, y is 2, x is -2, y is 0, x is 3, y is -4, x is 7, y is 0, x is 8, 9 and y is 5. So we get, so reflection over x-axis means multiply y with the negative sign. Remember, we need to do like this. -8 -5 -2 3 7 9. 3 -2 0 +4 0 and 5. And when we are going to plot it, it's going to be -2 with +3, -5 with -2, -2 with 0, 3 with 4, 7 with 0, 9 is basically going to come with, if it was 5, it should be -5. Over the y-axis, we need to transform -x and y. So we are going to get is 8, 5, 2, 3, 7, 9, -3, 2, 0, -4, 0, 5. 8 and -3, 2 and 5, 2 and 0, sorry, 8 and -3, 5 and 2, 5 and 2, 2 and 0, 3 and -4, and 7 and 0, 9 and 5. We need to change all x values. 8, 5, 2, -3, -7, -9. It's going to be like this. 8, -3, 5, 2, 2, 0, -3, -4, -7, 0, -9, 5. Okay. Over the line y is equal to x. So over the line y is equal to x, xy will become yx. -3 and 8, 2 and -5, 0 and -2, -4 and but the origin we're going to multiply with negative sign to both. So just remember, whenever you have to do over the x-axis multiply y values with negative sign, over the y-axis multiply x values with the negative sign, over the y is equal to x, change the coordinates x and y, and over the line y is equal to x, change the coordinate x and y, or in 180-degree rotation about the origin. 180-degree rotation about the origin, change both with the negative signs. f of x is this and g of x is find f or g or x. G of fx would be g f of x is x plus 3. Now this will become our x, so it would be x plus 3 square minus x plus 3 minus 12. For g of minus 3, put minus 3 square minus 3 minus 12 f inverse. So here we need to put f inverse 0 in the f inverse of x. So here I'm doing it, f of x was equal to x plus 3. Okay, it was y is equal to x plus 3. Switching x and y and solving for y. So f inverse x is equal to x minus 3. So we need to put the value of 0 over here, 0 minus 3. Graph the transformations of g of x. Tables are optional. First of all, we need to do first of all we need to make the table for the first one. Okay, so now putting the values of -9, 4.5 minus 4, 2 to the 4, 1 minus 1 by 2, minus 1.5 and minus 4. Here we're going to get 8, 8, minus 4, 6 and minus 8. So x plus 1 means x minus 1 and plus 2 means y plus 2. This negative means reflect. X means negative y values. Describe each transformation and write an equation for the new graph in terms of f of x. So the first function is f of x. What is happening in the second function? It's reflecting over x first of all, and if it is 2 over here, it's 2 going here. Reflecting over x and going downwards with plus 2. And what is this happening? It's reflecting over, this big one is coming here and this one is reflecting over y. So reflecting over y with how much, if it's here, it's coming here with 2. So reflecting over y and vertical going down by 2. Okay, so first of all we will find the remaining range of the function. The function is moving from -10 to 2, and the range is from -2 to 5. And domain of inverse and range of inverse is this inverse function. Okay, so finding the domain and how to find the inverse function, we need to do the alternate the x and y. So domain of the inverse function is the x values on the inverse function, that is from -10 to Next question is find the inverses of the following. So very easy to find the inverse in this case. Just switch x and y. Switch x and y. Find the equation of the inverse graph y is equal to x is the dotted line, and then graph the following relation and its inverse is the same set of x's. So first of all we need to graph the y is equal to x, then we will graph the function and its inverse with three different colors. So y is equal to 1 by 4 x plus 2. The inverse would be this would be the inverse. What will be the equation of the inverse? Switch is this inverse a function? Okay, 0 and 2, 4 and 3, minus 4 and 1, 2 and 0, 3 and 4, 1 and minus 4. This is, I'm doing for the inverse, I'm reversing the x and y coordinates. So it's going to come up with minus 60, minus 2 and plus 2 and minus 10 somewhere with this is the inverse one. The graph of x undergoes several transformations to create a new graph g of x. The graph of g of x has a domain of minus 2, 3 and absolute maximum at minus 1, 0. Does g of x have the same shape as f of x? If not, what dilations must occur? Okay, the graph of g of x is starting from minus 2 ending on 3 with maxima at minus 1, 0. Okay, so it has the same shape? No. What dilation must occur? Dilation, horizontal dilation by 1 by 2. This g of x is same direction as f of x. If not, for reflection, there is no reflection over x-axis. I have done the sketching. What transitions must now happen to move your sketch from the above map into the g of x? So you move 1 unit right. Write the equation for g of x in terms of f of x. G of x would be equal to minus f 2x minus 1. Verify if the following are the inverse functions or not. For finding if they are going to f g of x, which is equal to f x minus 15 by 7, which is equal to 17 by 7 plus 15, which is equal to x. G f of x, which is equal to g 7x plus 15, which is equal to x. So yes, they are inverse. Because we know for the inverse function the answer should be x and it's not x, it's x plus 4. Done with it. Determine algebraically whether each of the following functions are even, odd, or neither. So for even, so it's not even. For odd, analyze the graph at the right. F minus G1 means f of 1 minus g of 1 means f of 1 is, this is the function, and f of 1 is 0, g of 1 is -2, f -2, 0 minus 1 minus f -2 is at -1, g -2 is at -2, g -2 is at 7, sorry. F of 2 2 and g of 2 -1, g f of 3 4, g of 4 7, oh sorry, f of x should be greater than g of x. So from which interval f of x is greater than g of x? Domain of g of x is -2, -2 and 7. So domain of g of x is -2 to 7, becomes the input of f of x. The graph y is equal to f of x and y is equal to g of x are shown below. If f or g x is equal to -3, find the possible values of x, show the working reasonably. So it means if g of x is equal to -3, so if g of x is equal to a, f of a is equal to minus 3. So minus 3, the value of y is minus 3 at minus 2 minus 3 at 0 minus 3 at 0 and 2 3 4 So a will be minus 3 at 0 and minus 3. So g of x can be either 0, so x would be minus 1 and 4. G of x can either be minus 3, so x would be minus 2 and 5. Determine the composition f of g of h of x. G of x. New x is this 2. So here we're done with the revision worksheet of unit number 1. Hopefully you have enjoyed learning the worksheet.